Hi, my name is Elise. I'm going to talk to you now about the spectrophotometric determination of iron experiment. In this lab, you'll be finding the amount of iron in an unknown sample using a spectrophotometer, which is a machine that will measure the absorbance, or how much light is removed from a beam of light when it is passed through a solution that absorbs some of the light at a particular wavelength. You will be preparing a series of calibration solutions of which you know the concentration. You will start by preparing a stock of a standard iron solution by pipetting 25 mils into a 500 ml volumetric flask, adding water up to the line, and then mixing it really well. So remember, when you use a volumetric flask, to invert it and hold the top on, invert it many times. So when you have that ready, as I already did, you will be pipetting different amounts of the standard iron solution to make solutions with 0 milligrams of iron, 0.05 milligrams of iron, 0.1 milligrams of iron, 0.15 milligrams, 0.2 milligrams, and 0.25 milligrams. You'll see that they're colored. Now, our iron solution is not colored. In order to get that, first of all, we want to make sure all of the iron is in the 2+ oxidation state, not the 3+ state. So we'll be adding 4 mils of a reducing agent into every one of these volumetric flasks. It's called hydroxylamine hydrochloride. We'll then be adding 4 mils of a complexing agent called orthophenanthaline, which then complexes with the iron 2+ to give us this orange-red color. You'll see that as the concentration of iron increases, the color deepens. So just as a reminder on how to use the volumetric flasks, I've left this last one here to show you how to dilute it. So first you want to use your wash bottle to add water. You can add a little bit more quickly up to the bottom of the neck. But when you get there, you want to be careful not to go past the line in the neck, or your concentration will not be accurate. So make sure that you only add water until the bottom of the meniscus sits on top of the line. So when you have the water to that point, remember to put the stopper in and mix it really well. Prior to diluting, though, you'll note that your lab manual tells you to let the iron sit with the other two solutions for 10 minutes so that they make sure that they've reacted before you actually dilute to their final concentrations. So you'll also be then making a solution of an unknown iron sample by pipetting 10 mils of the unknown into a 250 ml volumetric flask and diluting that. I don't have the 250 ml volumetric flasks for the unknown here today, but you'll be preparing them by pipetting 25 mils out of your unknown solution into 2 different volumetric flasks and diluting them, so that at the end of running this calibration series, you will run those as well. When you have all of your solutions prepared and are ready to start using the spectrophotometer, you will prepare 2 cuvettes. Remember to handle them by the sides that are not clear, the sides that have the ridges on them. I've poured some of the blank, so this is the 0 milligrams of iron solution into one. And for the first part using the spectrophotometer, we'll be using the 0.15 milligram solution. This is the middle of the range of calibration solutions that you have prepared. There is a separate video on how to use the spectrophotometer, so I'm not going to go over that today. I'm just going to talk about what you'll be doing. In the first part, you need to find which wavelength gives you the maximum absorbance for your 0.15 milligram sample. This is so that you know which wavelength to test all of the rest of your solutions at, so that you have your absorbance in a good range, so that the Beer-Lambert law will apply to the relationship between absorbance and concentration of the iron. So you'll be starting at 460 nanometers and moving up in increments of 10 nanometers until you get to 540 nanometers. At every new wavelength, you will need to set the blank before you actually put in your iron sample. That is because in the blank, it's not just water, it also includes the hydroxylamine hydrochloride and the orthophenanthaline. That's because any light that these absorb we want to disregard that when we're measuring our iron. We only want to see the absorbance of iron. So at every wavelength, we will put in the blank first. We will set the spectrophotometer to 0 absorbance at that point, and then we will remove our blank. Remember to wipe the clear sides down if they're wet or if you've accidentally touched them. Put in our 0.15 milligram solution and have a chart in our lab notebook with wavelength in one column, absorbance in the other column. You will then scroll through every wavelength and test it, and whichever one gives you the highest absorbance for this iron solution, you will go back to that wavelength at the end, set the blank once because you'll be staying at that wavelength. You can measure this one again while you have it in the cuvette, the 0.15 milligrams. Then you will empty the cuvette and go through your series of calibration solutions as well as your 2 unknown solutions, having a chart now of concentration versus absorbance. At the end of the experiment, when you go home to work on writing it up, you'll be able to graph this and determine the concentration of the unknown iron sample.